Hello Angel, I'm going to try go through some mole calculation practice questions, like 2 or 3, just to make you a little more comfortable with doing them, and I'll be around tomorrow if you need any help with any further questions. So this first one is saying how many moles are in 24 grams of iron 3 chloride. Starting off, we're just going to figure out what is going to be our last step of this. Well, it's going to be shoving it into this equation which we spoke about, which is moles is equivalent to equivalent to mass divided by molar mass. And the way I like to remember this is if you think about making a batch of cookies, your mass is going to be how much cookie dough you have, your molar mass is going to be how much cookie dough you use per cookie, and your moles is going to be the number of cookies you can make. So let's say we have 40 grams of cookie dough, and then you have 5 grams per cookie. You're going to be able to make 8 cookies. Right? Now in this case, we have 24 grams of cookie dough, but they don't actually tell us how many grams we're putting into each cookie. So we need to work that out. And the way we work that out is first by figuring out what kind of cookie is it. So because they've said this in words and not elements, you don't actually outright have the letters to go to your periodic table and search for. So first we're going to figure out the charge of them, how we can make that into a compound, and then from the compound, work out the molar mass. And then obviously our last step is going to be just putting it into this thing and getting our final answer. So first off, iron 3. Let's suggest that. So you said that this 3 or the 2 confuses you, like you don't get what it means. So iron can actually take 2 different charges. It can either be 2 plus or it can be 3 plus. Now if you think of those as little puzzle pieces, you can either have a puzzle piece that looks like this, where it's got 2 things sticking out, or you can have a puzzle piece that looks like this, where you have 3 things sticking out. Now the reason why this is important and why they actually specify is because if it has 2 things sticking out, obviously it can only fit 2 things that go in. Whereas if it has 3 things sticking out, it can fit 3 things that go in. Seems pretty intuitive. So the way that you balance this, or make all of these smooth edges, in this case, is by first figuring out how many things are sticking out, and then you can figure out how many things are going to have to go in. So now that we've got that out of the way, we know that in this case it's 3 plus, so we can erase this, and we're just going to keep our puzzle piece that has 3 little prongs sticking out and make a little note here, writing out 3 plus in the number because it's a little less confusing. Now we need to move on to the chloride part to figure out what's going to stick in. And chlorine's going to have a negative charge. We know this because our iron has a positive charge and opposites attract. So, like your classic good guy with glasses, nerdy in class, and the goth mummy who pegs him. So we're going to need to look for chlorine in the periodic table and figure out the charge of the chlorine. So to do that, we're going to block out all of these middle columns. So you do 1, 2, skip a few. So you skip all of these few in the middle, and then you go back up, and then you count 3, 4, 5, 6, 7, 8. So instead of 13 and 14, that's not my pen. 3, 4, 5, 6, 7, 8. So these are the new numbers for our columns. Now, the charge of each thing in each column is going to be assigned by how far it is away from the far right side. So 8 is going to be 0, and then we just count backwards. -1, -2, -3, -4, etc. Now here you can actually start doing like +4, +3, +2, +1. But we don't even need to worry about that in this question, because if we look here, we can actually see that chlorine is, that color does not work. That color doesn't work either, but whatever. Chlorine's over in the -1 column, which means that chlorine's going to have a charge of 1 minus. So 1 minus is our chlorine charge. And if we draw that as a puzzle piece, it's actually what I drew earlier, coincidentally, where it has 1 hole sticking in. Now, because of that, we can draw this out. We're going to need 1, 2, 3 chlorine atoms to combine with that 1 iron 3 atom to be able to make a balanced equation. So, or not an equation rather, but a balanced molecule. So let's take that. We've got 1 times iron and 3 times chlorine. And so iron is Fe, which you can find in the periodic table up here. And chlorine is Cl, which we just found. And we're going to put a little 3 by our Cl because of the 3 here, obviously. So, perfect, we've got FeCl3. Everything from here is downhill. That's the only bit of actual chemistry you need to know. Now it's just math. So we go Fe, we have 1 iron, and so we go over and look at iron. The molar mass of iron is this little number down here, which is 55.845. And then we go look for chlorine. Chlorine is over here, which is 35.4527. Now, obviously, it changes slightly between periodic tables, so use whatever periodic table you have, but it will be somewhere in this ballpark. It won't be completely off. So remember, we have 1 of these, and we have 3 of these, and now we just shove that into a calculator. So 55, I'm just going to round for purposes, 0.8 plus 3 times 35.4. 0.5. And I'll put this into my laptop calculator since I don't have an actual one on me. 3 times 35.5 is 162.3. Perfect. Now we're going to take this, chuck a grams on it, and this is going to be our molar mass of our substance. So we come back here and fill it in. We have our 24 from the top, 162.3 grams for our bottom, which is our molar mass, remember? And then we're going to just put that into our calculator. 24 divided by that is around 0.15 moles. Now you round to the lowest number of significant figures in the question. So technically this should be 148, I guess. And there we go. So we've got 0.148 moles as our final answer. Again, I did a lot of rounding there, so that's probably not what you've got, but it will be somewhere close to that. Now, for your table, I don't actually know how it's supposed to be filled in, but it says answers are at the bottom of the worksheet, so if you send me those, I can explain why they're filled in the way they're filled in. But this is the answered question. I just don't know how it's meant to be formatted for you. So that's the first question out of the way. Again, it seems like a mountain to cross, but it's really just a molehill, and it's only difficult because it's your first time properly working through it. Now, the second question you've typed over, here, how many moles are there in 150 grams of sodium sulfate? Okay, that's difficult to read. Not one, question 2. I'll go moles in 158 grams of sodium sulfate. Now again, the only difficult part here is figuring out what sodium sulfate is. You saw once we actually knew what we were trying to do, in terms of what the compound was, then looking for the letters and the numbers and everything is really easy. So, sodium sulfate's a little bit more complicated because you need to know sulfate, which is SO4. I'll write that down here. And sulfate has a charge of 2 minus, if I recall correctly. These ions are something you can rote memorize, and I didn't, but I got lucky on my finals, and so they only asked about the ones that I knew. This is something I'm not really going to be able to teach properly. Maybe a YouTube video for it, but everyone I knew just used flashcards to memorize the ions. The sodium, on the other hand, is easy. That's just Na. And in terms of how we put them together, that's also simple. Remember, Na, we go look for the charge. Where can we find Na? Well, it's in this column over here. Now that's our 1 plus column. So Na has a charge of 1 plus. We already know that this is 2 minus. And so if we look at those puzzle pieces again, this sticks out 1, and this goes in. That's going in, and this goes in. Oh my goodness. Sorry, excuse the drawing, I'm not very good at art. This goes in 2. So we're going to need 2 of them to be able to fill in both those holes. So we have 2 times sodium and 1 times sulfate, which means we write it out as Na2SO4, because SO4 is our entire sulfate ion, right? Now, if we take this to the periodic table, we're looking for Na first. I'm just going to erase this because we've already gone through it. Give myself some writing space. Na, we found, is 22.9897 grams. Sodium is, not even sodium, sorry, sulfur is 32.06 grams, and then oxygen is 15.9994 grams. And if we take all of these 3 numbers, I'm just going to pull them down here. And remember, 2 sodium, I'll do this in red, 2 sodium, 1 sulfur, and 4 oxygen, because that's what we have over here. Now, we shove this in the calculator, 22.9897 times 2 plus 32.06 plus 15.9994 times 4 is 142.037. Now that's going to be our molar mass. Obviously, we're going to take that. We go our moles. Number of cookies is how much cookie dough divided by how much you use per cookie. And then I would suggest always writing out this equation first because you're showing working. And then you substitute your numbers in. Our original mass is 158 divided by 142.037 equals, bear with me here, 1.11239 moles, and then the lowest number of significant figures is 3, so 1.11 moles, rounded. Sweet. And you might want to just say to 3 significant figures. If you've been taught differently to the lowest number of sig figs thing, then don't worry about it. That's just the way I got taught in Australia. That's 2 questions done. I'll have a glance at the third, but if it's just a repeat, I might just leave you to it. Oh, there's not. Okay. This I will go through because it's different. But this one is a bit easier because you don't need to do the whole compound stuff. So, 3. How many grams are there in 2.3? Grams in 2.3 times 10 to the power of 24 atoms of silver. Now silver is Ag, and we can find that up here. Ag is, I just drew over the number, 107.868 grams. Sweet. And then drag this down here. That's our molar mass, obviously. Sorry, I just kind of squished it in there. Now, our molar mass is 107.868. Now this number of atoms, we're going to need to use Avogadro's number, or Avogadro's number, or whatever you want to call it, which is 6.022 times 10 to the power of 23. So if there were this many atoms, it would be 1 mole. But it's this many atoms. So we're going to divide this by this, and that's going to be our number of moles. So 2.3 times 10, divided by 6.022 times 10 to the power of 23 equal, oh my days, hopefully my computer can do this. Divided by 6.022 times 10 to the power of 23 is 3.8193. I'll just leave it there. You shouldn't round it in your calculator, by the way, just round on paper. And then we know that each mole of silver, according to this, weighs 107, almost 108 grams. We have 3.8 moles. You just multiply moles times molar mass equals mass. If you go, how many cookies do we have? How much does each cookie weigh? Is the mass of cookie dough in total, right? If we're using the same analogy as earlier. So we multiply these two numbers together, and that gives us times 7.868 gives us 411.98 grams. I've rounded it, and I should have rounded it earlier, to be honest. It should be like 410, I guess, because this is 2 sig figs. I'm a bit rusty on the sig fig stuff, but yeah, sweet.